right, graph f of x equals 1 minus 2 secant of 2x. So I'm going to rewrite that. Y equals negative 2 secant 2x plus 1. So we have a reflection. We have a stretch of 2. We have 2 cycles where there would normally be 2 pi. So the period is going to be 2 pi divided by 2, which is pi. So then we have a shift up 1. So like I said before, let's just go ahead and graph this as negative 2 cosine 2x plus 1. And then we just take those guidelines to create this. All right, so cosine. Let's just put in like our quarter marks, our key 5 points for a normal cosine graph. We're going to label this a little differently than I've been doing. 1, 2, 3, 4, 5, 6, 7, 8. How many lines do I have? Can I make that pi? 1, 2, 3, 4, 5, 6, 7, 8. Maybe that goes off my graph too far. 2 pi. It's okay. That's what I'm going to define. 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be negative pi. Okay. So our normal cosine graph would start at 1, and then halfway at pi halves would cross at 0. And then, so that's our first quarter mark. Halfway is going to be at pi. And then our 3/4 mark will be back at 0, and 4th quarter at the end is going to be back up to 2 pi. So that's where our normal cosine graph would go. Okay, so we've got to take all this other stuff into account. We're going to leave the shift up 1 to the very end. So we need to reflect this and stretch it by 2. And then we need to change the period to pi instead of 2 pi. So I'm going to go ahead and reflect it and shift by 2 first. So the point that's at, not shift, but stretch. So the point that's at 1 is going to be upside down, but then stretched. The 0 is still 0, times negative 2 is still 0. Negative 1 times negative 2 is going to put that up to positive 2. 0 times negative 2 is still 0, and negative 2 times 1 is going to put that point down at negative 2. So there's our quarter marks for our reflected and stretched cosine graph. Okay, now we need to deal with the period, the 2 cycles into pi. So that's just going to take all of these points and stretch them, or compress them in, right? So this would be there, and this would be there, and this one would come over to here, and this point would come over to here. So here's our entire cosine graph again. It's just half the size, half the period, because of the 2, because we can normally get 2 cycles where there was 1. That's what that 2 means. And we've reflected it, we've stretched it vertically, all of that stuff is done, right? Okay, at this point, we're going to stop and put asymptotes in, because we have to remember we're graphing secant. So secant is going to have asymptotes anywhere that this cosine graph crosses the x-axis. So there will be an asymptote here and an asymptote here. Where are those located? If this is pi, where are those asymptotes? Those asymptotes would be at pi fourths and then 3 pi fourths, I believe. So basically they would have originally been at pi halves and 3 pi halves, but because of that 2, we double that bottom number so that the, sorry, I just keep trying to make that look more like a 4 and I make it worse and worse. So that's fine. So there's our asymptotes. And so I kind of want to just dot this in here. There's our little cosine graph. So that means our secant graph is going to be a reciprocal of that. But let's not forget the vertical shift. So vertical shift means everything's going to be shifting. Oops, that's not quite what I meant to do. Grab that, drop there. So there's our midline. So where we did have cosine, it's just going to be all moved up from there. So you can sketch that in too if you'd like. I don't know, I'm running out of colors. Let's just do purple, but I'm going to change the transparency. Yep, it did. So I'm just moving that entire graph that I just did up one. All right, we're ready to do secant. Here we go. So this is going to reflect downward. This is going to be up from that peak point of the graph. This is going to be downward. If you want to, you could do a whole nother cycle so that you have your 2 cycles in 2 pi, or you could just do one fundamental cycle and that entire thing is going to go from 0 to pi with asymptotes at pi fourths and 3 pi fourths. We've got our minimum value here at 3 and this maximum, oh, I put that the wrong place now, it should be up there. And that maximum value at -1, so our range is from negative infinity to -1, and then 3 to infinity. And that's both because of the vertical stretch as well as the vertical shift.